Okay. Seems kind of odd talking to an empty room, but I'll go ahead and do it anyway. Last time we were talking about how the muscles know where they are and what's going on with them. And one of the ways they do that is with muscle spindles, and the other way they do it is with Golgi tendon organs. The Golgi tendon organs, of course, tell the body where the joints, the angle of the joints and whatnot, and whether the joints are carrying too much weight or not, they're doing too much, trying to do too much work. As I said before, you cannot, your body can't tolerate too much weight or trying, like lifting your car. Of course you can't. People have been known to lift cars, but if they do it without enough adrenaline in their system, they probably will be unsuccessful. Individuals that take steroids, of course, build their muscles to the point that the muscles are much stronger than they're supposed to be, therefore the joints can't handle it, and a lot of times they'll tear tendon away from bone, in which case they'll have to have it reattached surgically, and of course everybody knows that they have been using drugs, steroids. The Golgi tendon organs are somewhat insensitive to passive muscle stretch because they're connected to the elastic. Hello. I have somebody to talk to. This is good. I'm talking to myself here. So the Golgi tendon organs are somewhat insensitive to passive muscle stretching because they're connected to the elastic component of the tendon, and it is only activated under extremely heavy loads, or at least heavy loads. The Golgi tendon organs detect overloads that threaten to tear muscles and tendon, of course. And that is the purpose of the Golgi tendon, is to tell the human body whether they're trying to do something that they shouldn't do, whether they're doing something that will potentially damage the tendon. Of course, once you damage the tendon, it has to be reattached. Anthropologically, if we look back at humans in the past, when we didn't have surgical procedures to reattach tendons to bone, of course, that limb became non-functional, that joint became non-functional. Activating the Golgi tendon organs inhibits the motor neurons supplying the muscles that pull on the tendon, and thus by relaxing the tension prevents mechanical damage, and of course that is the purpose. This video has to do with building muscle. It's not very long, but it has to do with building muscle whenever it comes up.
The key to building muscle is protein synthesis and cellular repair. Skeletal muscle is made up of long fibrous chains containing proteins. Bundles of thousands of fibers make up the muscle itself. When an athlete engages in a heavy workout, this structure is damaged, causing micro tears in the muscle fibers. The body naturally repairs this damage by mending the torn fibers. The result is a muscle that is larger and stronger than before. And with each additional workout, the athlete adds bulk, strength, and speed.
Well, that's what I wanted anyway. This is kind of an interesting one. It would be. Yes, Amazon. Yes, Scott will join me.
What's going on, Asian? So I had someone come up to me in the gym this week, and they asked me why they couldn't seem to make any strength or size gains with their biceps. And so I thought, after I helped this gentleman out, that I'd make a video explaining to you guys the same things that I explained to him. And I said there's usually two reasons why you can't make gains with your biceps, and they both relate to range of motion. Reason number one is ego. Most people let ego get in the way, and they try to too much weight than they can actually handle for full range of motion. And the other way is just inexperience. inexperienced. The inexperienced lifter doesn't understand maybe what full range of motion is, therefore they just kind of copy what other people are doing in the gym, and if those people are usually inexperienced or have ego issues, then everyone's copying the wrong way to do bicep curl. And so what I'm going to do real quick is just show you guys what the improper range of motion is, and then help you understand why it's not going to do it that way. So, from the front, if you're working out in front of the mirror, you might not think you're doing this. And what most people do is they start up here, and then they do this. And they think this is full range of motion, because when you look in the mirror, it looks like you're doing a curl. But if you just turn sideways and look at yourself in the mirror, you would see there's really not much curling going on. You're just kind of moving the bar up and down with your a little bit of biceps and shoulders, maybe pushing through your triceps too, just to kind of throw it out there. What full range of motion looks like is the bar is all the way down by your hips and your thighs, and you're bringing it all the way up as high as you can, and then all the way back down. And you're keeping your elbows in front of your hips, all the way up, all the way down. You're controlling on the way down as well. You see how far the bar is away from my chest as I bring it down. Now there are different variations of curls, and some people claim they do this because they think they're hitting the peak of their bicep. Well, there are some exercises that I like to do that I feel do hit the peak of the bicep, and then one of them is drag curls. And even when you're doing a drag curl, you're still using full range of motion. And what a drag curl is, you hold the bar to your body and you drag it all the way up. And that just makes your biceps kill. It's a really great exercise. And there's another quick tip that I can give you guys. If you're trying to work the inside of your bicep, you want to get a wide grip on the bar. If you're trying to work the outside of your bicep, then you want to do an inside grip like this. There also is something, some people like talking about how if you do full range of motion, or if you go all the way down, you can damage your elbow. It would be extremely hard to damage your elbow going all the way down. Number one, your body's going to catch the bar before that would happen. And number two, you're always in control of the weight, no matter what exercise you're doing. The amount of risk that you have of getting an injury is super, super, super small. And I have yet to see anyone damage their elbow doing a bicep curl. Not to say it can't happen, but it's very unlikely. So, I hope you apply these quick tips to your next bicep workout. Let me know what you think.
Thanks, Scott. You're super.
Let me know what you think. And as always...
There we go. Okay, sorry. Yes. So Scott has to do all those lifts so that you can see his muscles rippling. And the reason he wants... This is one of the reasons why bodybuilders stand in front of the mirror, because they need to see their muscles working. And that's what he was doing. And he was absolutely correct. We cheat a lot when we bodybuild. Interesting fellow. Excuse me. Okay. There are two reflexes that are maintained by the spinal cord that are automatic and are not mediated by the brain. As a matter of fact, the impulse never gets to the brain. The flexion reflex is activated when the pain is applied to the leg. The muscles will contract, moving the affected part away from the stimulus. And those are the flexion reflexes. This is a video that shows all of the flexion reflexes. If you've ever had... You don't need to see that. Okay. The knee jerk response, the quadricep muscle is it contracted to allow the knee to bend. It's informed of the tendon pressure that makes the muscle react by stretching. Thus, the stretch reflex. If you've ever had an athletic physical, they did this to you to make sure that your reflexes were okay. The primary lateral cortex, the M1, controls all the muscle movements in the body. The hands and the lips utilize the biggest portion of the area compared to the percentage of body that they represent. And of course, if we took this whole area, as you can see, the lips are very large. And the hands are very large. The rest of the body, not so big. But of course, that's the area that you need covered more than any other. So the M1 communicates with the rest of the body through the pyramidal system. Pyramidal system is a triangular-shaped bundle of nerves that runs from the brain through the medulla and into the spinal cord. Lesions in the system will result in the inability to move select joints and limbs. So you have to be careful not to get a lesion in that area. Those neurons that run from the M1 to the muscles that are not in the pyramidal system are said to be in the extrapyramidal system. These neurons control spinal reflexes, and of course, now I'm going to show you a video about the spinal reflexes, I hope. Yes.
The lower body reflexes will be performed in the same manner as the muscle strength exams were performed. We're going to test one side and then quickly test the other side and compare side-to-side responses. We've got 5 reflexes that we're going to go over, one being the knee reflex, one the Achilles reflex, and then the adductor reflex, the internal and external hamstrings. The first one will be the knee reflex. I'm going to have the patient close their eyes, strike the tendon. We got a good response. I want you to keep your eyes closed. Strike it again. Got another good response. Now the Achilles reflex. I'm going to just slightly dorsiflex the foot by reaching underneath the foot and letting her rest the foot on my hand. And then I'm going to reach back and I'm going to tap the Achilles tendon. And I got a real nice plantar flexion of the foot. Comparing side to side. I have the patient lay face down. Now we can do the adductor, internal and external hamstring all in this position. If I want to test the adductor, I'm going to have the patient medially rotate the leg. I find the adductor tendon along the medial side of the leg. I've located it, and I'm going to strike over the tendon, and I get a slight contraction of the adductor. For the internal and external hamstring, I just have the patient lay flat. I locate the tendon by slightly having the patient bend their knee against resistance, bring the leg up. I'm going to push down. And the tendons pop out quite easily. You relax the leg. I've got the tendon located, the medial hamstring tendon. I'm going to strike the tendon, and I'm watching for contraction and slight flexion of the knee. On the lateral hamstring, I locate the tendon, and I'm going to do the same thing, strike the tendon, and watch for contraction of the hamstring as well as slight flexion of the knee.
Okay. All the reflexes, and of course he was doing all 5 of them rather than just the knee reflex. If you've ever had a physical, they probably only did the knee. Yeah. Okay. The extrapyramidal system communicates with the spinal cord through 2 tracts: the reticulospinal tract and the rubrospinal tract. The extrapyramidal system not only handles spinal reflexes, but of course they are responsible for breathing muscles that control the head and the neck, and that is the end of that chapter. I'm glad there are 2 of you here, because the next chapter that we have to talk about is sex. Okay. Kind of an interesting chapter. I've got the balloons. Let's celebrate them. So we're going to talk about the evolutionary, hormonal, and neural bases of sex and why sex is the way it is. We, of course, are primates, therefore our sexual response is different than cows and dogs and cats and whatever, and other mammals. There's 4 stages of sexual response. Oh, good, another person. That's wonderful. That makes it even better. I'm signing in for you guys, so don't feel odd, but I'm not handing this thing around. So there's 4 stages of sexual response, and of course, as scientists, we can talk about this without anybody getting nervous or confused or feeling like they're being attacked or whatever. The first stage of sexual response is sexual attraction. Of course, this is different in all species. There is a different way of responding to this aspect. In most species, sexual attraction cannot take place until the female is ready to reproduce. Of course, as primates, we are always ready to reproduce. Well, let's pretend we're always ready to reproduce, and we can reproduce at any moment. But a dog or a cat, they have to go through estrus in order for them to respond sexually. This is one of the reasons why you don't see dogs just humping out in the yard all the time. It's because most of the time they can't. You can judge sexual attraction by looking at how the females and males are reacting to one another. I have a male puppy and a female dog. I don't think she's fixed, but he is. Of course, and there are other male dogs in the area. And of course, the male dogs are not attacking my female dog, mainly because she's not in estrus, so she is not receptive to sexual attraction. You can judge sexual attraction as to whether the male approaches the female, how rapidly they approach, how they approach the female. The female, of course, at this stage will show attraction to the male by whether she allows him to approach her. If she's really in heat, if a female dog is really in heat, then initially she will try to chase the male away. She will attack him, and he will respond to her by not harassing her. Eventually, of course, when she is ready to have intercourse, then she will allow him to approach her. In many mammalian species, the female will demonstrate her approachability through swelling in the vaginal area. That is, a different color and an odor is regulated by a surge in estrogen. So there's an odor and a color difference as far as her vaginal opening is concerned. Most species, intercourse is impossible unless she fully cooperates with the male. That's the only way that it can possibly work. So that's the sexual attraction phase. The second stage is the appetitive stage. Behavior that establishes, maintains, or promotes sexual behavior. When a female is displaying this behavior, she may approach the male. She may stay close to the male. She may show alternating approach and retreat behavior. My dog was doing this the other day. Like I said, I don't think she's fixed. I'm pretty sure she's not fixed. So what she was doing, she was running around in circles, and the males were just kind of standing there and not really understanding what was going on. And she was running around, then she was laying down flat, and then she was running around again, and they were chasing her, and it was an approach and retreat behavior. All the males in my area are fixed, so it wasn't like she was going to allow any of them to mount her. She may move in a specific manner that will result in the male mounting the female. That usually involves her backing up toward the male. This is known as proceptive behavior. The male appetitive behavior may consist of staying near and sniffing the female, and that's pretty much all that the males do, except fight each other. They will fight each other for the right to breed the females. A lot of times what will happen to breed the female, what will happen is the two largest males will fight each other, and then a third male will be the one that actually breeds the female. As interesting as that is. So the two biggest males usually beat each other up, while the third largest male is the one that actually gets to reproduce. The third stage is coitus. It's copulation. It's where they actually have intercourse. And of course, what all that they are doing in reality is that they are merging their gametes. They're merging the semen with the ova, and of course, that's what they need to do in order to reproduce. It begins when the male penis is inserted into the female's vagina, and this is known as intromission. Through rhythmic movements, the male will then squirt sperm-filled semen into the female's reproductive tract. Rhythmic movements can last for moments, for mere seconds, or it can last for an extended length of time. After copulation, the two will go through a period where they will not be able to re-engage in intercourse, and this is known as a refractory phase. However, a male presented with another female may show a shorter refractory phase, and this is known as the Coolidge Effect. And the reason this is known as the Coolidge Effect is because once upon a time, Calvin Coolidge was president of the United States. And Calvin Coolidge was touring a farm in South Dakota with his wife. And let's see, how does this work? So they're walking along, and there was a rooster and a bunch of hens. And the rooster was having intercourse with all these hens. I mean, and it was one right after the other. And Mrs. Coolidge said to Calvin, "Look how responsive he is. Look how responsive he is." And he said, "Well, if I had that many hens, I would be that responsive too." And that's why it's called the Calvin Coolidge Effect. The idea being that every time you're presented with a new female, then you're more receptive of intercourse. And if you have sex with the same individual over and over and over again, then you go through a refractory phase, if it's the same individual. So it takes more time to respond the second time, or the third time, or the fourth time, or the fifth time, or whatever. When a female is ready to copulate, she will be sexually receptive, of course, and sexual receptivity is an aspect that we will be discussing later. Post-copulatory behavior, this is different in most species. The males of all mammals, but primates, achieve and maintain their erections with a bone in their penis, known as the os penis. And I had a picture of os penises, but evidently it didn't take. Wait a minute, maybe I'm in the wrong thing. Wait a second. Was that a picture of os penises? They're not that exciting, as you can imagine. Huh, I wonder what I did with it. Okay, well, that's fine. Here, let's go back. Sorry about that. I fixed that thing. Okay. Anyway, os penises. Sometimes, as with dogs, the male is unable to remove themselves from the copulatory position for minutes after the ejaculation. If you've ever seen dogs reproducing, a lot of times they get stuck and they can't remove themselves, and the female's trying to pull back, and it seems to be hurting her, and she's crying, and of course it's hurting him, and he's crying. But the reality is that it takes a couple minutes for the bone to retract back into the abdomen, so that the male can remove his penis. Why? Why would they do this? Why would this be the way it works? Why wouldn't the bone immediately retract so that they can pull out? Can you think of any reason why them staying in that position for a number of minutes would be positive for either one, either the male or the female?
I don't know if it's positive, but reproduction.
Yeah, well, it's more likely that the semen will be able to travel for the sperm to travel. That's a possibility. It also keeps another male from having intercourse with it. There you go. I know. So so he's more likely, the first one to have intercourse with the female is more likely to reproduce with her. Now the reality,
Third guy.
I'm sorry?
The third guy.
The third guy, yeah. The first and second guy are beating each other, the crap out of each other. So whoever wins the fight, he gets to go next. And that's one of the reasons that female dogs have such a bad reputation. They will accommodate all the males in the area. And I have seen dogs that have given birth to puppies of different breeds because different breeds had bred with her. There was not just one male that had intercourse with her, so she had 3 or 4 different species. I know, it's really kind of odd. I had a wife once upon a time. I have a wife now, but it was a different wife at that time. She had a Cocker Spaniel, female Cocker Spaniel, and that dog had 6 puppies, and there were 3 different breeds. And of course, my wife thought it was funny that, and she used to refer to her dog as a slut, I guess, in essence, because she had sex with so many different breeds of dog. Anyway, that's my ex-wife. The whole purpose of copulation is the joining, of course, of the male and female gametes, the ovum, the female, of course, and the sperm and the male. If the two join, the ova will become fertilized and the union will become a zygote. While all mammals, birds, and most reptiles fertilize inside the body, internal fertilization, fish and frogs fertilize outside the body, and that's known as external fertilization. And I didn't read that quite correctly. So there's internal fertilization and external fertilization. If the species lays eggs outside the body, as birds and reptiles do, it is called oviparity, egg birth. If the species allows the zygote to develop in the female's body, it is referred to viviparity, and that's live birth. Viviparity just means live birth. So there you go. We have oviparity and viviparity. And as humans, of course, we are viviparious. For most creatures, there's only one sexual position that they can be in for copulation to be possible. Since most mammals walk on all fours and have a tail, reproduction can only take place if the female raises her rump and moves her tail to the side. This will usually straighten her vagina adequately for penetration, and this is known as lordosis. Cats are this way, dogs are this way, not especially the ungulates, cows, sheep. Their vaginal opening, their vagina is relatively straight, but for a cat, they have to stick their rump in the air and move their tail over to the side, and they have to put a bend in their back in order for the vagina to be straight enough for the male to actually be able to penetrate them. And this is known as lordosis. It's an interesting position. If you've ever had a cat in heat or a dog in heat, if you've ever watched a dog or a cat, they'll get into this position in order to reproduce. It's the only way they can do it. Otherwise, the vagina is there's a bend in the vagina and the penis can't penetrate the vagina. For frogs to mate successfully, the male must mount the female. As you can see in that top picture, he is on top of her. He doesn't penetrate her with his penis. The female emits her unfertilized eggs, and the male must release the semen at the same time. And that's one of the reasons why he's there, is to bathe the ova coming out of her vagina with semen. This has to be done over water. If it's not done over water, then of course they will die. This position is known as amplexus, with the male on top and the female on the bottom, her squirting out eggs and him squirting semen on top of them. And that's what they look like when they have been fertilized. they turn into little tadpoles. Eventually they turn into tadpoles. While sexual response is extremely complex, the female anatomy for intercourse is relatively simple. There are two folds of skin that cover and protect the vaginal opening. These are the labia majora and the labia minora. The female erectile tissue is the clitoris above the vaginal opening, and that is pretty much it for the female. Males a lot more complex actually. They have to deliver the gamete. It requires penetration by the male. The male system is far more complex than the female. Erection takes place due to an engorgement of blood, since we are primates, and so that's the only way that we can have an erection. Semen is produced in the testes and it's stored in the epididymis. During ejaculation, the sperm travel up the vas deferens, past the seminal vesicle, the prostate gland, and the Cowper's gland, where it picks up a viscous alkaline fluid called semen. Now, one of the interesting things about humans is that in order to protect the female reproductive area is relatively acidic, and because of that, the semen that the male ejaculates has to neutralize the reproductive area, and it does that with an alkaline fluid. So the alkaline fluid actually neutralizes the acidic reproductive area. The reason that her reproductive area is so acidic is to protect her from bacteria and viruses and whatnot. So anything that potentially gets into the vaginal opening, it will die because of the acidity of the reproductive area. So the male, in order to reproduce, has to produce an alkaline fluid. Now the interesting thing is we've developed these three glands that produce an alkaline ejaculate. All three of these glands. If one of these glands isn't working properly, then the male will not have an alkaline enough semen and he will not be able to reproduce. And I've seen this over and over and over again. One of my jobs as a laboratory technician was to check to see if the male was viable, if he was producing a semen that could potentially impregnate the female. And if his fluid, if his semen wasn't alkaline enough, then he wouldn't be able to reproduce, which is kind of interesting. We had one individual that had a blockage in his Cowper's gland, and of course, unless you go in there, you dig around in there, you can't figure these things out. And they didn't want to do surgery. What they wanted to happen was for it to become unplugged on its own. So he would come in every week and produce a semen specimen, and we had to check it for alkalinity, and it just wasn't quite alkaline enough. At the time he was married, and when his wife found out that it was potentially him that was causing them not to have a child, she divorced him. She got rid of him. So you think, okay, so that we don't have to worry about this guy anymore. He's not going to be coming in because he didn't have a wife. But he still came in every week, and eventually he had a girlfriend that, and we continued to check his semen. We checked it for about 1.5 years, every week for 1.5 years. That was a lot of fun, as you can imagine. And eventually he did unplug. Something happened and it did unplug. I guess all the story is good. He got his girlfriend pregnant, and then she left him. Sorry. I know, sad stories, I apologize. Normally the male is not erect because cells in the glands of the penis, the paragigantocellular cells, the nucleus, what a wonderful name, paragigantocellular nucleus, sends serotonergic fibers down the spinal cord that inhibit erections. Otherwise, males would walk around with constant erections, and of course we don't. So that is kind of a positive thing that this takes place. During sexual excitation, the forebrain inhibits the PGN and allows the penis to become erect. Selective serotonin reuptake in her, it's a serotonergic fibers, so it has to do with serotonin. Because of the serotonin in the system, the male is able to maintain himself or to control himself from having an erection all the time. So when he becomes sexually excited, a substance that is regulated by nitrous oxide, as odd as that seems, is released, and he's able to maintain an erection. Now the reality is that this system would have a male with an erection all the time if it didn't control it with these serotonergic fibers. I know, this sounds kind of weird, doesn't it? Okay, so a male would be walking around with an erection all the time, but of course he doesn't. And why doesn't he? He doesn't because of this control system, these serotonergic fibers that run into the spinal column. Okay, so what if he's taking selective serotonin reuptake inhibitors? What if he has an excess amount of serotonin in his system? One of the things it will do, it will not allow him to have an erection. Potentially it won't, if it's enough serotonin. Okay, so the number one drug in the world is, no big surprise, Viagra. And I know Viagra. How odd is that? All those men with erectile dysfunction. So how does Viagra work? What Viagra does is that it blocks the paragigantocellular nucleus. It blocks that serotonergic fibers and allows the male to have an erection. That's what happens. That's why Viagra works. There's 3 of them on the market right now. Cialis, Viagra, and Levitra are the 3. But
how does this tie in with the what is it? You said the vagus nerve, right?
Right.
How does that?
The vagus nerve allows the whole system to function. Everything runs down the vagus nerve. It's right in the middle. Right in the middle of your body, which is a good place for it. I mean, it needs to be protected. Like I said, I saw a guy that, it was a fairly superficial wound, but it severed his vagus nerve, and there's nothing we could do. He died. He's gone. So yeah, I know, a little strange. While there is no normal or typical when it comes to sexual response, too many social and psychological factors, and of course, your culture tells you to talk about sex in one way. My culture tells me to do it in another way. We went to Japan. The Japanese are completely different. Chinese are completely different. We go to Europe. We see a lot of nudity in their commercials. In the United States, we don't do that, but of course we do have the angel ladies, Victoria's Secret people wandering around in their underwear, which seems a little odd, but of course in Europe we saw that back in the 70s. Anyway, so society society tells us how we can respond to sex. This is really kind of bizarre. If you go to other cultures, they will tell you that in our culture we think that the male is more sexually responsive than the female is. But in other cultures it's the opposite. And this is one of the reasons why. Have you ever heard of female circumcision? They do it in Africa. They believe that the female is more of a sexual animal than the male is. So they have to control the female sexuality. Anyway, so there's just tons and tons of social and psychological factors as far as sex is concerned. The normal sexual response is that the woman will achieve vaginal lubrication during the excitement phase. The males will have a smaller amount of lubricating exudate during erection to ease penetration. Males typically have one basic pattern of response, but they do pass through a refractory phase after orgasm when erection is difficult. Females, on the other hand, they don't have a refractory phase. Thus, they can have multiple orgasms, whereas a male normally can't. The female does have 3 typical patterns of response. One pattern is intercourse, and then they will have a relatively long plateau, and then they will have an orgasm. The other response is a relatively quick response where they have an orgasm fairly rapidly. And the third one is where they reach a plateau and they never get beyond the plateau. They actually don't have an orgasm. And then they go into the resolution phase after intercourse is finished. So those are the three basic responses. One is very quick, one is relatively prolonged, and the other one is has a relatively long plateau with a short orgasm. Okay. The male response is almost always exactly the same. In many situations in nature, the males and the females of the species are very much different in size as well as structure. In most vertebrates, the male is larger because he must battle other males for the right to reproduce. Remember, we were talking about the dogs, and the two big dogs are the ones that are fighting each other for reproductive rights. And number 3 is the one that actually gets to go first and probably reproduces with the female. Another definition of sexual dimorphism is that the male gamete is abundant, small, and cheap, while the female gamete is large, rare, and expensive. Let's see. If a male reproduces, he can reproduce over and over and over again with different females, and potentially he can produce that many offspring. If a female reproduces, she gets impregnated, and it takes her 9 months. In humans, of course, it takes her 9 months to have a child, to reproduce. Of course, the male can have sex one day with one woman, and the next day with another woman, and the next day with another woman. He can produce all those 267 children in the same time that she can produce one child. So his gamete is fairly abundant, it's small, and it's relatively cheap. And the female gamete is large, rare, and extremely expensive. So which one is worth more, the female or the male? I'm sorry?
The female?
The female. Definitely the female. Sure. It's one of the reasons why we dress our men up in funny clothes and throw a weapon in their hands and throw them out to war. It's okay. We don't have to worry about it. We can kill off all the men that we want. All we need is one guy. That's all we need to stay home, is just the one guy. Of course, everybody's volunteering to be that one guy. No, they're not. They're all volunteering to go overseas. Because of the low cost of producing sperm, males can easily gather enough nutrients and energy to impregnate millions of women. I know, millions of women, really? Who was I reading about? Somebody had sex with 10,000 women in his lifetime. Oh, Wilt Chamberlain. Yeah, Wilt Chamberlain. Sure. Now, the problem is finding 10,000 women that want to have sex with you. Of course, he was really tall. I guess that had something to do with it. Whether males are selective or not, the odds are that they will have some offspring that survive. Females, on the other hand, have to be more selective, of course. There are stories about Elvis Presley having, dozens of children out there. Officially, he only had one child with his wife, but theoretically, he had sex with all these different women. And of course, groupies are always around rock stars, I guess, and baseball players and football players and basketball players and whatnot. So they tend tend to be able to reproduce multiple times. There's a reason why I have a picture of J-Lo. If we think of J-Lo, J-Lo has had lots of boyfriends and several husbands. One of her boyfriends was Ben Affleck. They didn't reproduce. As a matter of fact, she didn't reproduce with anybody except the last guy. She didn't have any babies until she had the set of twins with Mark Anthony. I think that's his name. Females that carefully nurture their costly eggs are more likely to have offspring that survive to be the next generation. The better you take care of your children, the more likely they will survive. And of course, she must be very careful as to who she reproduces with. She doesn't want to reproduce with somebody that is weak and may potentially not survive. So what she's looking for, she has to select a male that appears to be somebody that will be able to survive. Males that carry many beneficial genes are more likely to provide the female's offspring with favorable genes. But how does a woman do this? Now remember, we were talking about pheromones, and I told you that pheromones give a immune system fingerprint. So a female, and everybody has flaws in their immune system. So potentially a female would be attracted to a male, or she would be attracted to a male who would correct something in her own immune system. This is one of the things that we discovered when we started looking at pheromones and trying to determine why pheromones exist. So a female that is attracted to a male who smells good to her is more likely to have offspring that will survive. And there she is with all three of her husbands. I don't know if she ever married P. Diddy. He's the first, I don't know. I know she married the guy on top. He was a dancer, one of her dancers. And of course, Mark Anthony's a singer. And I think he's shorter than she is, which is kind of interesting. But they've had a set of twins. I don't think they're together anymore. I don't care. It's not important. She was very selective. She liked his voice, and that made him a good candidate for reproduction. The female must closely observe the appearance and behavior of the male. A vigorous, healthy male is more likely to carry good genes than an unhealthy one. Thus, courtship is a period when the female assesses the genetic makeup of the male to judge the suitability as a mate. Okay, we're doing this online now, which is kind of curious. So I'm not exactly sure. I don't know what's going to happen next. Maybe humanity will just collapse because of the internet. That's a possibility. Females aren't selecting males, the most appropriate male. Then potentially our population will be sickly in the future. If we aren't responding to pheromones, which we were in the past, then potentially we will produce offspring that are very sensitive to different things like different diseases. And of course, there are diseases out there that potentially could wipe out whole populations. The Zika virus, for example, is one good example. The hantavirus is another one that is in this area. The hantavirus, Ebola virus, all of these things potentially could wipe out the human population if we are not careful. We have seen this in the Jewish population. Jewish people only marry within their own religion. They're supposed to anyway. It doesn't always happen, but when we saw this happening with the Ashkenazi Jews, first of all, they were segregated into villages, into ghettos. That's where the word ghetto actually comes from. They put them in ghettos. And because they were in ghettos, were only able to reproduce with each other, then they started inbreeding to some extent. And because of that, Tay-Sachs disease has developed just in that population, just in the Ashkenazi Jews, the Eastern European Jewish populations. And it may have been because of those isolated situations, because they were isolated in those ghettos. Now your population is really kind of fascinating because your population is very strict as to who you can reproduce with, in essence, who you can marry because of your clan system. And of course this is a very positive thing as far as producing offspring that will be able to survive in the future. So here we can look at the Jewish population and we can see that they've had this neurological problem that has reared its ugly head. It's a very painful thing to watch because the child, as the child grows, they grow out of their neurological system. And by the time they're 1 year old, they're barely functional at all. They can't lift their heads, they can't do anything. And of course they will die within the first 2 years of life. So potentially you should be looking for somebody, you should be seeking a reproductive mate that will produce healthy offspring. And of course that's the first thing we talk about when a baby is born. Look how healthy it is, look how loudly it yells, how the healthy child is what we're looking for. And of course with all of its select body parts, it's got 5 fingers on each hand, 5 toes, 2 feet. Anyway. Okay, so how do we select who we want to mate with? There are 4 mating strategies that are used in the animal kingdom to ensure offspring survival. The first one is promiscuity. In other words, just having sex with as many people as you possibly can. These are 3 prostitutes from the wild, wild west. And of course, they were relatively promiscuous. But of course, if you are too promiscuous, then potentially you'll pick up diseases, and that won't work out very well. It's also the same for males. I mean, if a male is too promiscuous with too many different women, then potentially he'll pick up interesting sexually transmitted infections, and he will have problems in the future. Females will mate with more than one male, or as many as they can in any mating season. Of course, this works with dogs and cats. It doesn't work with cows so well. Of course, we control the breeding practices of heifers and with sheep, ewes, for example. This will ensure that the male with the most attributes is going for him, that has the most attributes going for him, is more likely to be the sire of her offspring. And of course, that's one way to do it. Another way is what we call polygamy or polygamy. It is where the male maintains a harem of females that he will exclusively mate with. Most ungulates mate in this fashion, as do gorillas and the elephant seals. They've done studies with elk and with deer, and what they've discovered is that while the male is trying to protect his females, there's rogue males that are wandering into the herd and reproducing with his females. And the level of reproduction that he is doing is only between the 50 and 75% range. So the other females are actually producing offspring from other males, because the female, of course, doesn't really care who she reproduces with. It's the male that's trying to protect his harem. He's trying to keep other males from reproducing. And of course, in different parts of the world, males are allowed to reproduce with a number of females to maintain harems. In the Middle East, of course, this is relatively common. Africa, this is relatively common. With the American Indian, pre-Columbian American Indians, this was relatively common. It was relatively common in the northern plains and in the southwest, but not so much in the southeast and the east. In the southeast and the east, the females were in charge of things. They owned everything, and so a lot of times they didn't practice polygamy, they practiced polyandry. They would have more than one husband. The Shawnee, for example, a woman would have a house, and that was hers. The males, she would marry a male that was that was living in the village. If he went off to war or whatever, if he left, then she would select another male to reproduce with, another male to protect her and to feed her and her family. So she would maintain a house, and she would have different husbands coming in. The interesting thing would be if her other husband came back, what would happen is he would send a message into the village that he was coming in, and he would ask his wife if she would allow him to live in the house. And if she said no, he had to stay outside. He couldn't come into the village. That's the way it worked. Well, those were Shawnees. They were a little bit different than everybody else. Actually, the Cherokee were very similar. The southeastern tribes are very similar. The females were the ones that owned everything. They owned the land, they owned the food. All he owned was his what was on his back, his equipment, his soldiering equipment, and whatever he could kill. So, of course, that's what he had to offer her was meat. Polyandry is rarer than polygamy, but is still known to occur, of course. In polyandry, one of the women will mate with more than one man, but those men can only mate with a single female. This is practiced in Tibet. The women tend to marry brothers because they get along better. Actually, in polygamy, they tend to marry sisters because they tend to get along better than people that aren't related to one another. But it's the same way with polyandry. They tend to marry brothers. This is very common in Tibet. It's actually gaining access down in South Africa, in Zimbabwe and Botswana. These women will marry more than one man. And of course, the more men that are in the house, the more likely that she's going to be taken care of. And that's the way it works, polyandry. Monogamy is the most prevalent mating method among humans. In monogamy, a pair will form a mating pair where the exclusive access is maintained between both the male and the female. This seems to be the best manner in which a woman can gain resources from the male when he must provide for the children to ensure that they will survive. So monogamy forces him to take care of his own children. So there you go. That's why monogamy is so common. It's relatively common. Sexual selection takes place when the female selects the male that they wish to mate with. It's usually the female that does the selecting. Sexual selection among birds is the most garish of all creatures. In order to attract a female, a male will weigh himself down with impossible structures, such as the peacock's tail. And of course, the larger the peacock's tail, the more likely that he will be able to find a hen who wants to breed with him. Some species participate in intricate mating rituals during courting that are not only garish, but call attention to themselves from predators. Almost all male birds have intricate songs that they sing in the spring during mating to attract a female. In some species, courting is quite extensive. Among large cats, only vigorous exercise over several days will bring the female to ovulation. In other words, he has to chase her for days. Now, how does this take place? The cheetah is the one that is the most common. The cheetah, they have to run for 3 days without stopping, and of course they get tired. So how does the male do that? Does the male chase the female for 3 days? Not usually. What will happen is a group of males will chase a single female, and usually brothers, and whoever's there when she ovulates is the one that reproduces with her. But they will chase her around the plains for days in order to get her to ovulate, as odd as that may seem. If you've ever been to a powwow and you've seen grass dancing, grass dance is the prairie chicken, is the bird that they're emulating. And it's one of the reasons why they have the feather on the top that waves back and forth. And they get down with their arms up like this and they dance around. It's the prairie chicken. It's a sexual dance. You know, it's okay. It's kind of like in Hawaii where they dance. Okay, so humans do kind of the same thing. These are the Wadabi, as curious as they are. They're the funniest looking guys, and that's one of the reasons why I chose pictures of the Wadabi. They're from Niger, and Niger is where the 4 soldiers died, the 4 Green Berets died, and it's caused so much conflict all of a sudden. In order for them to reproduce, they have to charm the females, and they do this with eye movement. As odd as this may seem, as you can see, he's crossing his eyes. Actually, one eye is looking out, and the other eye is looking in. And if they can move their eyes independently, they're more likely to find a female that will want to have something to do with them. I've got a film of these guys. They're really kind of fascinating. They're nomads. And at select times during the year, they will all dress up in their best outfits and paint their faces and start moving their eyes. And the women, it's wild watching the women respond to them. The women are so cool, they don't respond at all. They don't smile, they don't do anything.
The Wodaabe are part of the Fulani nation. They live as nomads along the southern edge of the Sahara. Despised by all neighboring peoples, they are called Borobos, something like herdsmen in tatters. They call themselves Wodaabe, those under the taboo of purity. They consider themselves the most beautiful people on this earth. The earth does not belong to anybody, they say.
Did you hear that? They're the most beautiful people on earth. Other people call them herdsmen in tatters, but they call themselves, I can't even remember what they call themselves. What do they call themselves? They call themselves those under the taboo of purity. So they're the only pure humans. As exciting as that is. I'm sorry, let's go. Okay. We'll start again.
Something like herdsmen in tatters. They call themselves Wodaabe, those under the taboo of purity. They consider themselves the most beautiful people on this earth. The earth does not belong to anybody, they say. It would only belong to mankind if they were herdsmen of the sun.
allowed to smile. Oh my goodness gracious. The most beautiful people on earth. Okay. Okay, that's the way the Wodaabe do it. They the men make themselves up and the women get to select which one they want to have anything to do with. This is the Maasai. This is the way the Maasai do it.
Tomorrow be disciplined, be determined,
We ever get
but
it.
tonight just be. Dr. Teals.
Everybody gets a smile on this one. Those are the women. Oh, those are the men, I'm sorry. Where's the women? There's the women. There are the women right there. Whoops. There you go. Who jumps the highest is the one that, kind of like basketball, I guess. A woman who selects her mate by who's the best basketball player. It's okay, anyway. You notice the one with the lion's head. In order to become a man in the Maasai culture, you have to kill a lion, and he has killed a lion. The rest of them haven't, and that's why he's got the headdress. And of course, you can see that that makes it look like he's jumping higher. That makes it. Oh, there we go. These are the Maasai women and the Wadabi women, the most beautiful people on earth. The Wadabi women. These are the Wadabi women. And those are the Maasai women, as you can see. I don't know. That's how they select their mates, by jumping. And of course, in the United States, we select our mates by who can play the best basketball, who's got the outside shot, or not. I don't know how we select mates. I'll have to admit that my wife picked me right off the softball field. I was playing third base. I had the biggest stick, so I hit more home runs than anybody else, and that's why she selected me. It's really kind of curious. Anyway, okay, sexual differentiation takes place among most humans while still in the womb. The sperm either carry a male or female chromosome. All ova, of course, are female. Therefore, it is the sperm that decides whether the gamete is going, or whether the zygote is going to be a male or a female. Thus, males are a heterogametic sex because of the two different chromosomes, the X or the Y. And the females are homogametic, homo meaning same, and hetero meaning different. So if we are heterosexual, it means we are attracted to different genders. Homosexual means that you're attracted to the same gender. Very early in the development, the gonads are not differentiated. There are indifferent gonads, and for this reason, you can't tell if a zygote is going to be a male or a female. They haven't differentiated the sexual parts yet. In the mammals, the Y chromosome contains an SRY gene that is responsible for the development of the testes. If the individual has a Y chromosome, the cells of the indifferent gonads begin making SRY protein. The SRY protein causes the core of the cells to proliferate over the outer layer of cells, and the gonad becomes a testis. And that's what a male looks like. Just kidding. If that's what a male looks like, this is what a female looks like. Wait a minute, maybe not. If the individual has no Y chromosome, no SRY protein is produced, and the indifferent gonads form with the outer layer dominant and the inner core is inhibited. As the fetus begins to form, they develop two ducts that connect the indifferent gonads to the cell wall, the Wolffian duct and the Mullerian duct. If bathed in testosterone from the testes, the Wolffian duct will develop. If not, the Mullerian duct will develop. And of course, if it's the Mullerian duct that develops, it becomes ovaries and a vagina. If the Wolffian duct is dominant, then they will produce testes and a penis. If the SRY protein is released by the Y chromosome, the gonads become testes and bathe the area in testosterone. The testes produce testosterone, and that's just about all. They do two things. They will produce sperm as the individual matures, but they also produce a lot of testosterone. And of course, since they produce so much testosterone, the individual becomes a male. The Wolffian duct develops into the vas deferens, the epididymis, and the seminal vesicle. The Mullerian duct will disappear at this stage. The genital tubercle becomes a penis, and the genital fold becomes a scrotum. If both the chromosomes are X's, the gonads become ovaries. The Mullerian duct develops into the fallopian tubes, uterus, and inner vagina, and the Wolffian duct disappears. The genital tubercle becomes a clitoris, and the genital fold becomes the labia majora and labia minora. Okay, so what if we have a hermaphrodite? A hermaphrodite is somebody that has both male and female body parts. So what if that happens? That will happen if the fetus is, it's a zygote at this point. If the zygote is producing too much testosterone, then potentially, but not enough to keep the Mullerian duct from developing. So that's one of the things that will take place. That's one of the reasons why people become hermaphrodites. Now the reality is that it's extremely rare. Hermaphrodites are very, very uncommon. I don't know if you've ever seen a picture of a hermaphrodite, but of course they look like they have both organs, sets of organs are intact. The reality is that one will be dominant over the other. So they will either have female responses or male responses. Okay. Testosterone from the testes releases a hormone called the anti-Mullerian hormone that shrinks the Mullerian duct. It causes tissue around the urethra to form a prostate gland. It causes epithelial tissue around the urethra to form a scrotum and a penis. The epithelial cells have 5-alpha reductase, which converts testosterone to dihydrotestosterone, which allows masculinization. And of course, that's one of the reasons why males are so masculine, is because of all these things taking place. And all that excess amounts of testosterone that are splashing through the system. We're going to talk about the brain. One of the things that happens, of course, is that the brain develops differently in a male than it does in a female. The male brain is larger. There are structures that are different in the male brain and the female brain. Does that make the male more intelligent? No, it doesn't have anything to do with intelligence. As a matter of fact, you could argue that the female brain is actually more intelligent than the male brain. And that's because her corpus callosum is about 11% larger than the male corpus callosum. So the left hemisphere, this is my right hand, the right hemisphere and the left hemisphere are able to communicate better in the female brain than in the male brain. If a sperm, or let me see what time it is. Do I need to stop? Why don't we stop right here? Why don't we stop right here, and we'll pick it up right on this one. We're almost finished actually with the chapter. Fascinating chapter. I like the Wadavi the best.